Hey everybody, it's Jenny from Norman S. Wright. Let's continue on with another topic on water loops in HVAC systems. This week I want to talk about open versus closed water loops. So let's get started. In last week's video, I explained the condenser, primary, and secondary water loops in a chilled water system, and I drew this image. In this system, there are closed and open loops. In a closed loop, the water circulates in a sealed system without being exposed to the atmosphere. The same fluid is recirculated continuously, transferring heat to a heat exchanger or other components. Our primary and secondary loops are closed loops. The water circulates through the equipment and piping without ever leaving the closed system. In an open loop, water is circulated through a process where heat exchange happens outside of the loop. The cooling tower is a good example of this. I'll put a link to the cooling tower intro video I did a while back, but basically water is sprayed into the cooling tower. When it's sprayed into the cooling tower, it's open to the atmosphere. Because it's open to atmosphere, cooling towers lose some of its water volume through evaporation. Cooling towers have drift eliminators to capture some of the evaporated water, and they can also use makeup water to replace evaporated water and drift losses. Let's move this over and look at a few differences to be aware of between open and closed loops. First, let's talk about heat transfer. In an open loop system, heat is rejected to the environment, whereas in a closed loop system, it relies on heat exchangers like the evaporator and the chiller and the cooling coils in the air handler. Water consumption is another difference. Open loop systems require makeup water to replace evaporated or lost water, while closed loop systems use less water since they recirculate the same fluid. Water contamination is something else that needs to be considered. Open loop systems are more prone to contamination since the water is exposed to the outside environment. This can lead to scaling, biological growth, and corrosion. Let's scoot this up. Closed loop systems are less susceptible to contamination since they are sealed. Move it up again and look at some other things to consider. Open loop systems may have higher heat rejection capabilities. They're also subject to weather conditions. Outside temperatures can affect their efficiency. Closed loop systems are usually better at controlling temperature and humidity in indoor environments because the water isn't exposed to the environment. So let's pull all this back on screen. So that covers open loop versus closed loop systems and some considerations that you should know when you're using either one of them. If you have any questions or topics you'd like me to cover, leave a comment below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.